Geologic timescale. The geologic timescale. The geologic timescale has major eras, and this timescale is created by the paleontologists. These are the scientists that study about the past of the Earth. Their study is based on relative dating, absolute dating, theories, record in rocks, and fossil records. All of these concepts here will be discussed in the coming slides. What are the different major eras in our geologic timescale? These are the Precambrian era. This is about 4.6 billion years ago. Another one is Paleozoic, which is about 542 to 251 million years ago. Another one is Mesozoic, which is 225 to 65 million years ago. And the last era, which includes the present time, that is 65 million years ago up to now. The Precambrian era. The Precambrian era is the formation of our Earth. Basically, the Precambrian era is the majority of the timeline of our Earth's past. This is also signified by the formation of life. Life from a unicellular organisms to a simple and multicellular organisms. The unicellular organisms begin as a prokaryotic cell. They are actually the primitive type of cell. And these prokaryotic cells are called anaerobic because they do not require the process of using oxygen. These unicellular organisms later became a cyanobacteria, and these cyanobacteria are actually photosynthetic type of organisms. In other words, they are the one that introduces oxygen into our atmosphere. So this is the historical background of the Precambrian era. The Paleozoic era. The Paleozoic era is the evolution of life in land, and the example to this one are the mosses, the ferns, and the amphibians. But prior to the evolution of life on land, it also evolved first in the ocean. An example to this are the algae, the fish. So this is the evolution of the life on land and in the ocean. So this is the Paleozoic era. Mesozoic era is dominated by the evolution of organisms on land. An example to these are the evolution of birds, evolution of reptiles that lead to the age of the dinosaurs, and flowering plants are already showing up. At the same time, the primitive mammals are also evolving that will lead into the next era, which is called the Cenozoic era. So this is the Mesozoic era, the evolution of organisms on land. Cenozoic era. During the Cenozoic era is dominated by the evolution of primates. That is, that primates evolution includes now the binocular vision, including there is also the opposable hands, and the hominids, the coming of the hominids. An example to this are the evolution of man from the Australopithecus about 4.4 to 1.4 million years ago, to the Neanderthals 2.6 million years ago to 11,000 years ago, and eventually to the Cro-Magnons our ancestors 48,000 years ago, and now the present day. The early Filipinos are depicted in this presentation. The geologic time scale is based on absolute dating, relative dating, that is based on theories developed through times. This is also based on records found in rocks that include sedimentary rocks and relative fossil remains. While fossil records include preserves or amber, for example, preserves the entire organism, petrified woods, exoskeletons, coal, DNA remnants. Absolute dating. Absolute dating determines the actual ages of past events. In here, I will only introduce a couple of absolute dating techniques that are used. One is the use of tree ring. Examining tree rings is actually a concept called dendrochronology. In dendrochronology, scientists will examine the variations of the tree rings found on trees. This will help the scientists to indicate the particular climatic condition in the past. Actually, this type of method of dating will also help or aid the scientists to tell the age of the wood specimen. So that is called dendrochronology or tree ring method. Another type of absolute dating is by means of radiometric dating. This is utilizing the concept of a half-life. For example, a fossil can be extracted and processed in a laboratory to determine the amount of this radioisotope that is decomposed into the environment, and that will help determine the or estimate the particular time that fossil was still alive, and that will help also determine the age of the particular specimen. And again, that radiometric dating will also determine the time. So that is the absolute dating. Relative dating principles. So basically, relative dating principle is not a kind of absolute dating that it utilizes tree ring at the same time the radioisotopes, but rather through the different theories and principles developed along time. For example, the theory or the principle of uniformitarianism. It is telling us that the past events can be explained by the actual geological events that happens today. For example, we are going to study about superposition. It is simply telling us that the upper layer in our crust is actually the younger event that is happening in our geological process compared to the one that is found beneath the layer of the surface. So that is the principle of superposition. And to support that, according to the theory of or the principle of original horizontality, that the original sediments are deposited almost in the horizontal layer. So meaning to say that when there is happening of deposition of sediment, and according to the superposition, that is actually the younger event that happens in our geological process. However, if it is true, then all of the sediments that is deposited along a continuous direction, or also known as lateral continuity, is also true. So what happens, for example, in a particular area is also the same in a long distant area, because as it is mentioned that all that is happening on the surface are actually the younger version of the geological time scale. While that is true, however, sometimes there is what we call a cut of rock, and we call this the intrusive relationship. And if there is an intrusion of a new type of rock, meaning to say that intrusion is actually the younger rock compared to the surrounding environment. And for example, for faunal succession, if it is fossilized, then you can find fossils that at the bottom are actually the older event, and fossils found on top is actually a younger event in the geological time scale. And for example, inclusion and components. In other words, older fragment rocks can be embedded, for example, a volcanic event. So when there is a lava flow, it engulfs in the older rock. So in other words, what is included inside a lava is actually the older rock, and the outside rocks are the younger version of the geological time scale. And finally, although it's true that all of those original horizontality that in the horizon, those are just simply the deposited sediments, but for example, if there are faults, we call this the cross-cutting relationship, wherein faults will actually shift the position of older rocks so that the older rock can surface out actually much greater in elevation compared to those younger rocks. So these are the different relative dating principles that are also utilized in determining the history of the geological time scale.